Hey, boys and girls, guess what? We are finishing chapter 10, and yesterday you should have put all your answers from 10.13 on Google Classroom with your answers, and now we are doing a review, and this will cover chapters 8 through 10. And the reason we do review is because we want to make sure you did not forget what you learned. Now, this one's a little different. Because it's review, I'm not teaching you anything new. So here's your instructions for pages 300, pages 303 to 304. What you need to do right now is stop the video. Then go finish the pages on your own. Then play the video for review and make corrections. Okay, so what are you supposed to do? You're going to stop the video, go finish the pages on your own, then play the video for review and make corrections. So some of you are just going to turn off the video and not come back. No, I don't want you to do that either, because I want to make sure you actually get these right and you still remember how to do it. Now, seriously, stop the video. Play it again when you finish. Love you. See you soon. Okay, so if you are back watching this video, you have all of these answers filled in and you are just checking your work. If not, stop the video now and come back. All right, so those of you who are with me, all of these are filled in. You're going to make corrections as you need to. If you need to erase and make corrections, can you pause the video? Absolutely. All right, we are on 10.14. This is a review of chapters 8 through 10. Nothing new, just review. All right, it says label each right, obtuse, or acute angle. Acute. Oh, that's a cute little angle. Obtuse. Do you remember these, boys and girls? Hopefully you do. A right angle is a perfect square corner, just like this. So this one's right. If you got it right, you're right. Obtuse. That's anything bigger than a right angle. Do you see that? It's bigger than a right angle. So this one's obtuse. Oh, this one's a cute little angle. Remember the cute ones? The acute angles are the little ones that are smaller than a right angle. So this is acute. And this other one that's bigger than a right angle, it's obtuse. Obtuse, it's bigger than a right angle. Hopefully you remember these. I'm glad. If not, make corrections. It should come back to you. This part says, complete the chart. Do you remember line segments and angles? A circle, boys and girls, a circle. How many line segments are in a circle? Here's how you remember. Look, what's the shape of a circle? 0. How many line segments do they have? 0. There's no line segments. It's one giant continuous curve. How many angles do they have? 0. That one should have been the easiest for you. Okay, triangle, triangle. Tri means 3. Ooh, like tricycle. Guess what? That's the answer to our question too. How many line segments? 1, 2, 3. That's the 3 segments on each side. 1, 2, 3. How many angles? The spots on the corner. I'll tap it with a different color. 1, 2, 3 angles. 1, 2, 3 angles. Tri means 3. That's your answer right there. There's 3 line segments and 3 angles. Rectangle. Here's our rectangle. How many line segments? 1, 2, 3, 4. How many angles? Let's check the corners. 1, 2, 3, 4. Did you get that? Excellent. Keep on going. Ooh, do you remember these? We had our pattern on the board. We had slides. We had flips. We had turns. The first one is an S. The S stays here and then it scoots over. What's another word for scoot? It slides. Nothing changed. It just slid over. So it is a slide. And what will be the next, what will the next one look like in that pattern? It's going to look exactly the same. It's just going to be scooted over. That's a slide. All right, boys and girls, let's look at this one. This one is, let's see, the E is going this way. Then it flips back the other way, almost like a mirror. Do you see that? If we were to have a mirror here. Now, if we were to put another mirror right here Do you see how that flips? Whoop, it flips to go to the other direction. So what will the last one be? It's like it's looking at itself in the mirror. A flip. So it's like the E is looking at itself. So that is the last one, and we know that that is a flip. Good job. Okay, this T is turning. A turn is like when it moves around the clock. Like you turn in a circle. So the T, the top of the T is right here. Then the top of the T is right here. Sometimes with boys and girls, to help myself remember, I just look at one part of the figure and then move that and then add the rest. So my T is turning. So then it will be like this. And almost like it just did a little turn. It was sleeping on this side, stood up, and then laid on the other side. Your T will lay that way. Awesome. If you got your T turned the wrong way, change it. If you got your E turned the wrong way, change it. Do you know why you got it wrong? Does it make more sense now? Good. I hope so. So we had a slide, a flip, and a turn. All right, moving to the next section. It says, draw the shape for each ordered pair for number 11 and 12. So remember, it's over, then up. This is over, then up. If you went in the wrong order, you're going to get the wrong picture. So 3 over, 1, 2, 3, up 1. Where am I at? What shape is that? That's the blue triangle. Okay, if you went backwards, and I'm going to do it in reds, this is what you don't do. If you went up 3 and then over, you have this figure here, and that is not it. Remember, it's over, then up. Get rid of that one. We don't want that. Okay, 4, 2. Over first, over 4, then up 2. What did you get? The red circle. If you did not get that, I want you to fix it now. So remember, over, then up, over, then up, over, then up, over, then up. Okay, now it says, write the ordered pair for each shape. Same thing, over, then up. And it needs a parentheses to be accurate. If you didn't put parentheses in there, do that right now. Over, so I'm looking at this green triangle. How many did I go over? Over 2, comma, it needs a comma also. Then up 4. Do you see that? Here's the 4. So it's 2 over 2, up 4. Now let's look at our purple square. How many over is it? It's over 1. Don't forget your parentheses. Over 1, up how many? Up 3. Over 1, up 3. If you got that right, give yourself a high five. If you give yourself lots of high fives in a row, it'll sound like you're clapping. Try it. True story. If you got those and you're done making corrections, we'll move on to the next page. It says, measure each line segment to the nearest ½ inch and centimeter. They're already labeled here, inch and centimeter, inch and centimeter. So you got a ruler out. Now, when you're looking at a computer screen, depending on how big your screen is, I can't put a ruler to the screen because it's not going to match your book. So if you used your book and you measured to the nearest ½ inch, rounding up or rounding down to the nearest one, you got about 3 inches and about 8 centimeters. If you measure the next line, I can tell that it's shorter. How much shorter? Sorry, this is actually nearest ½ inch. Boys and girls, we know halves. So it was actually 2½ inches. If you don't believe me, measure it again. And it's about 6 centimeters. Okay, so if you didn't get that to match, why don't maybe you didn't put, remember the 0 goes here, not the edge of the ruler. The edge of the ruler is usually here, and the first 0 on your ruler starts, and then you have your ½ inch, and then you have your inch, 1, okay? Make sure that when you measure, it starts on the 0, not the edge of the ruler. Not the edge of the ruler at the 0. Maybe that's why you got tricked. Okay, it says write the temperature. Don't forget to label, boys and girls, because Fahrenheit and Celsius are very different. Okay, so what is this? 40. If you put 41, I'll tell you why you're wrong. And I want you to fix it. You have to see how much does this go up by, because this is a difference of 10. The difference between 40 and 50 is 10. So let's see, how do we get there? If this was 41, 42, 43, 44, 45, that would be 45, but it's not. It's 50. So each of these is worth what? 2. So this would be 42, 44, 46, 48, 50. So this is not 41, boys and girls. It is 42 because each of those mini lines is worth 2. So this is 42 degrees. Keep that up high. Fahrenheit. Do you see that? Okay, let's look at the next one. Again, this goes up by, let's see, it's 100, 110, 112, 114, 116, 118, 120. These each go up by 2 degrees. So what is the answer here? This one is, what is that? 10, 12, 14, 16, 18. 118 degrees what? Fahrenheit. If that was Celsius, it would be extremely, extremely hot. But at 118 degrees Fahrenheit, still burning up if you're a human, but it could reach that temperature outside in hot desert areas on a hot day. Let's see, next one. These again go up by 2. 22, 24, 26, 28, 30. So this is Celsius. Let's see where it stops. So this is 22 degrees Celsius. Excellent. Okay, again, these ones go up by 2, not 1. So we have 102, 104, 106, 106 degrees Celsius. That is crazy hot. We never hit that temperature on here on Earth, unless you're talking about underneath the Earth. But our weather will never reach 106 degrees Celsius. Okay, circle the better estimate. Okay, so we're thinking in our mind, this is from our measuring chapter, a kangaroo's tail. Is it 30 feet? Now, 30 feet, boys and girls, each floor of a building is about 10 feet. So if you're looking at like a 30-foot building, it's like a 3-story building. Are kangaroos' tails 3 stories long? No, they're not. An average person is about 5 feet tall. So 30 feet would be like 6 people tall. Is a kangaroo's tail 6 people tall? No. 30 inches though? That sounds about right. A kangaroo's tail is about 30 inches. A boomerang. Do you remember boomerang? We're doing a lot of Outback stuff here. A boomerang. Is that about 3 ounces or about 3 pounds? They're very light and they fly back to you. 3 pounds is, let's see, we buy a big a pound is like a bag of coffee from Starbucks. They have the big 2-pound bags at Costco. 3-pound bags would be even more than that. 3 pounds is more than Presley's kitten. That would be too heavy of a boomerang. It's about 3 ounces. Soda bottle. Okay, a gallon, like a big thing of milk is a gallon. A soda bottle is not that big. They are measured in liters. A 2-liter bottle, and that's actually what they are. It's not even an estimate. Like, they're 2-liter bottles usually. Kangaroo hop. How far can a kangaroo hop? About 10 feet. About 2 people. If you have 2 adults laying on the ground, can a kangaroo hop that far? Or is it about 10 kilometers? Now, kilometers is similar to a mile length. Can a kangaroo hop that far? No, that's not it. They'd hop about 10 feet. Okay, if you did not get those, switch them now. Okay, next section. Here we go. Write the fraction or mixed numbers. This is a review from the chapter we just did. So remember, for our fraction, the numerator's the part, the denominator's the whole, and fractions are parts of the whole. So the numerator. The numerator's the part. How many do we have? 1, 2, 3. There's 3. And how many in the whole? Well, 3. Let's keep going. 4, 5, 6, 7, 8, 9, 10. So 3 out of 10 with 3/10. That's our fraction. Awesome. Next one. The numerator is the part. How many do we have in the part? 1, 2, 3, 4. So that's our numerator. And how many whole altogether? There's 5. 4/5. Do you see that? 4 parts out of the 5 total parts. 4/5. Excellent. Ooh, boys and girls, this is a mixed number. And what does a mixed number mean? Number with a whole and a fraction. So there's the whole and then the fraction. So do we have to write 3/3 here, or can we just count this as one whole? Yeah, count it as one whole. So there's 1. And what's the fraction here? Well, there's 2 parts out of the whole of 3 parts. So this is 1 2/3. Do you see it? Hope you got it right. Excellent. All right, next section. Some more review. You should not have forgotten this because we just learned it. When you compare greater than, less than, or equal to, these all have the same denominator. So the only thing we need to look at, this one might trick us, 31 might trick us a little bit, but I think you know it. The only number we need to compare is the what? The numerator. So if you have a pizza cut into 6 slices, what's more, 3 slices or 1 slice? 3, of course. If you have a pizza cut into 5 slices, what's more, 4 slices out of that or 5? Yeah, and we know that 5 out of 5 is a whole. So that would be the whole thing. That's definitely bigger. Okay, let's look at the next one. If I have a pizza sliced in 8 slices, what's more, 6 of those or 5 of those? When the denominator is the same, remember you just compare the numerator. So what's more, 6 slices. There we go. Boys and girls, don't be tricked by this one. 1 is the same as, if we made this into a fraction with the same denominator, this would be 8. Now, a whole is how many slices out of that? All of them, right? So 7/7, 6/6, 2 seconds, 5/5, 8/8. So what? 8/8 equals 1. And we know because 1 equals 8/8. So these are equal. If you got that, good job. If not, fix it. Last section. We just did this too. I hope you remember. Green. And Mrs. Kornthal loves going this way. I love going this way. And it's the same thing because we know our fact families. The opposite of multiplication is division. That's why this works. So in my mind, I think 7 times what equals 14? 7 times 2, 7, 14, 21. So 7 times 2 equals 14. What I do to the bottom, I also do to the top because I have to split them equally. So times 2. 3 times 2 equals, you know this, 6. If these aren't coming fast to you, can you work on your multiplication facts while you're at home? Yes, please make it a game. Get on Math Playground. Do some of those video games. Yes, I said play video games. Don't forget you have that. Okay, let's go this way again. Change your arrow. Get rid of that times. 10 times what equals 40? 10 times 4. Remember, anything times 10 out of 0 to the end. So 4 times 10. And then what I do to the bottom, I also do to the top. So 9 times 2 equals 18. So 9/10 is the same as 18/40. Wow, that would be lots of slices on a piece of pizza, for sure. Okay, let's turn our arrow the other way and get rid of the division. We're going to make a multiplication. 3 times what equals 9? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 3 times 3 is 9. Excellent. What I do to the bottom, I also do to the top. 3 times 3 is 9. Some of you said, Mrs. Kornthal, I already knew this because look, watch. You'll start to see the pattern. 3 over 3, 3 parts of 3 is one whole, right? And so if I know this is a whole, what would be a whole here? 9/9, right? Do you see how that equals 1? Just wanted to show you that. You'll start making those connections soon. Okay, let's go back to the math. Here we go. Turn your arrow the other way. Get rid of that division sign. 8 times what equals 24, boys and girls? 8, 16, 24. So times 3. 8 times 3 equals 24. What I do to the bottom, I also do to the top. times 3. 5 times 3 equals 15. Yay. If you got all of those right, I am so proud of you. If you missed some but figured out why you missed it and you were able to fix it, good job. That's how we learn. If you are super confused, boys and girls, that tells you if you missed a lot, I want you to go back and review. Go back to the pages in all of these chapters and look it over again, because the more you practice, the more you learn. So good job. Good job. And see you next time. So this is Mrs. Kornthal's. I'm not teaching on the whiteboard. This is my mishmash of cursive. This is usually what adults do once they learn cursive and they just want to write fast. See you next time. Love God, love your neighbor.